So in this case, we are going to consider our typical exam revision as we are preparing for the controlled tests, which are going to be written in March. As we know, guys, for our grade 11 mathematics, as part of your SBA, you are going to be given a controlled test in March that you are going to work on. So this is a typical exam question which you're going to work with from our Gauteng province, which is the Johannesburg West district for our term one. And as we can see, this is the exact control test in our previous test that we had. That was the first push that we had. All right. So it was like a preparation. So this was their final part that they wrote in March. So guys, it was 50 marks, 1 hour. I'm not gonna waste much time, guys. We had the basics, now the introductions. So everything is just gonna be smooth, guys. All right. Unless for trigonometry. All right, I'm going to actually work on it. Yes, I'm gonna work on it as a I'm gonna work on it, guys. A lot of things that I need to add that you need to prepare for your exams. Also check the nature of roots. I have worked on that video on the nature of roots, the introduction as you requested, and and some question papers. Gonna add some question papers on the nature of roots. If there are still questions, guys, let's communicate. That's the purpose of the comment section. Let's communicate. So that is it, guys. If necessary, answers should be rounded off to 2 decimal places unless stated otherwise. So read all other instructions. Let us quickly rush through our questions. Question number 1, solve for x. Solve for x. So 1.1, we are already given 2 brackets, all right, equal to 0. Remember the 0 product, a times b is equal to 0. It is either one of these two must be equal to 0. This is the condition. It is either a is equal to 0 or b must be 0. So this is our condition. We've got a and b. So either one of these 2 brackets must be equal to 0. So that was the concept of your question. So you're going to take, that's 1.1, the first bracket, x plus 2 must be equal to 0, or the other bracket, which is 3x minus 1, must be equal to 0. So let's solve. The 2 to the other side was going to be what? A negative 2. All right. It was a positive, or simply subtract 2 both sides. So this is going to cancel. So that's 0 minus 2, which is minus 2. On the other side, the minus 1 to the other side was going to be what? A positive. So 3x is equal to 1 divided by 3. This is a product. So you're going to have the value of x, which is what? 1 over 3. So these were the 2 possible values of x, guys. Minus 2 or x, which is what? 1 over 3. Just like that. So guys, there it was already factorized for you. It was just a matter of extending from what you're given. 1.2, correct to 2 decimal places. As we are solving this equation, correct to 2 decimal places. So once you're given this, it is either going to use your quadratic formula or completing of the square method. But first thing, the format of the quadratic equation, are we having that? No. The format of our quadratic equation, ax squared plus bx plus c is equal to 0. So one side must be equal to 0, meaning to say we are forced to transfer this to the other side of the equation. So that was going to be something like this. 6x squared as it is, right? There is minus x. You take the 4x this side, so it will be what? Minus 4x. So it's minus x minus 4x, which is what? Minus 5x. You take the 4 to the other side, it was going to be what? A minus 4. So that's equal to 0. So this is the format first of your quadratic equation. Then we write our formula to solve this equation. Remember your formula, x is equal to what? Minus b plus or minus the square root of b squared minus 4ac, like this. Everything over what? 2a. So substituting our values, what is representing our a? As we can see, the coefficient of x squared, b, the coefficient of x, C is our constant. So that is the case. So meaning to say, we are going to substitute this as x is equal to what? Minus our b, the coefficient of x, which is what? -5. Right? Plus or minus the square root of b squared, the same b that we had, that's -5 squared. -4 times a, our a was 6, and our c is what? -4. So this is it, guys. We've been now working with this type of equation. 2 times your a is what? 6. So this is it. Like I always say, guys, make sure that you present this part under the square root. Minus and the minus, that's +5, plus or minus the square root of what? What is this number that you're going to have? Now that you have done the nature of roots, as an introduction, now I think it is clear why I always say, please present that part that is under the square root. So just simplify these numbers under the square root. -5 squared -4 into what? Into 6 into -4. Okay, just even use multiplication there. All right. Oh, I forgot the 4 there. -4. So that was going to be 121. So this is the number that you're obtaining under the square root, 121. 2 times 3, 2 times 6, sorry, that's a 12. So guys, just from this number that you're obtaining, which is 121, without even solving our equation, without solving further, finding the value of x, we can even tell the types of roots that you're going to have at the end because of this number that is under the square root. 121 is a perfect square. So we expect definitely to have what? Real roots, which are what? Which are rational. Which are rational, but what? Unequal. From our nature of roots. I'm just explaining just for you guys to understand. Because we make that as an introduction. But anyways, this was not part of your question. Just use your calculator. You'll see that our roots, they're going to follow exactly these 3 conditions that we are going to have. One is going to be real, rational, and unequal. So let's simplify and see. Put the fraction 5 plus the square root of what? 121 over what? Over 12. So that's over a 12 like this. So as you can see, guys, 4 over 3. That's a real number. Rational. It's a rational number. Remember, this is 1, 3 with a dot that, remember that dot that you put on top, which is endless. 1, 3, 3, 3, 3, and so on and so on and so on and so on. But it is what? A rational number, this one. Can be written as a fraction, a over b. All right. So guys, as we're not worried about that, let's just take our answer. Remember, they said to 2 decimal places, 2 decimal places. So that's 1,33, or just simply shift, go to the setup, fix 2 decimal places. It's going to be 1,33. So that's 1,33, or x is equal to, we put a negative this time here. Let's see. That's a negative. So this was going to be -1 over 2. As you can see, guys, it's a fraction. That's a rational number, right? So changing this to 2 decimal places, that's -0,050. Remember, they said to 2 decimal places. So you must have 2 digits after the comma. 2 digits after the comma. So that was the idea of the question. Just like that. You can use completing of the square method. You can use NPAT. So in this case, there are even factors in our case, but when they say to 2 decimal places, guys, don't waste your time on factorization. Just use your quadratic formula or completing of the square method if you are used to that one. All right. 1.3, again, we are solving for x, but now we've got an inequality there to consider. Right, let me take this one aside so that we properly see our question here. So that was 1.3. 2 minus x into 2x plus 3, like this. It is greater than x minus 2. So this is what you're given. According to your inequalities, now we cannot tell Is it a linear? Is it a quadratic? Expand brackets and see what's going to happen. After the expansion of brackets, then you can see, but in your mathematical view, yes, you can just have that option to say, okay, it's going to be a quadratic, but for now, let's expand brackets here. 2 brackets. How do you expand? So 2 is going to multiply every part there. So that's 2 times 2 there, which is 4. So it's going to be 4x. Same thing, 2 times 3. All right, so the 2 here multiplies the 3. 2 times 3 is going to be what? 6. We are done with that 2. It multiplies everything. So we move on to the negative x. Negative x times 2, that's negative 2x squared, x and x. So it's going to be negative 2x squared. Negative x to the 3 there, that will be negative 3x. This one to this one, it's a negative there. Positive, negative, so it's going to be negative 3x. That's greater than x minus 2. We have expanded. We can see that there is the highest exponent there, which is what? Which is 2. So that's a quadratic inequality that we are talking about. Right, no problem, no problem. Let's simplify first the left-hand side and see. Do we have any like terms? We do not have for minus 2x squared. It's just going to remain as it is. But for this part of x, on the left-hand side, we've got the 4x here, and we've got the minus 3x. So 4 minus 3, that is going to give us what? 4 minus 3, that's 1. So it's going to be positive x. Then the 6 is not having any like term, just remain as it is. That is greater than x minus 2. As we do understand working with the quadratic, once we have a quadratic, is it from a quadratic equation, guys? We understand this. Even from our quadratic inequalities, the format, they follow the same thing. Ax squared plus bx plus c, whatever is going to be greater than is going to be less than 0, but it must be compared to a 0 there. But look here, this left-hand side is being compared to what? X minus 2, not to 0. So we have to get rid of this until we have a 0 here. So what can we see? What can we do? Take the x to the other side and the minus 2. We have to transpose these to the other side of our inequality. So we are going to have minus 2x squared. Originally, there was a positive x there. You take this x to the other side, it will be minus x. So x minus x, that was going to cancel, all right? You move on to the 6. They originally, on the left-hand side, there is a 6. You take the minus 2 to the other side, it becomes what? A positive. So 6 plus 2, that's 8. So that was going to give us what? A positive 8. So that's plus 8, which is greater than, remember, the purpose of taking these to the other side is so that we remain with what? A 0. Compared to 0. So this is where you are. So you can solve this, find your critical values as it is like this, guys. I'm not saying it's wrong. You can solve like this. Or you can even make this to be positive. How can we make this to be positive? Simply divide by negative 2 throughout. So that was going to cancel negative, negative. So we've got x squared. 8 divided by negative 2, that's a negative 4. This is what we have. So we have a negative 4. And look into the inequality here. We are dividing by what? A negative. Once you divide by negative like this, 0 divided by negative, or whether it was 1 divided by negative, whatever that you have. But the moment you divide by negative, the inequality sign, this one, it reverses, it changes. So it will be like this, less than. It has to change. Inequality sign changes. So we are going to have a less than 0. Inequality sign there reverses once you make a division by what? A negative number. So that is the condition. That is the condition. So you now have a new inequality now. This part, guys, We now have a new inequality because of this division that just happened, guys. This is a new question, this one. It's like we now have a new question that we are supposed to put our focus on. Let's say the question was, solve this. How are you going to solve this? That is the condition now. You now have a new question. How are you going to solve this? Factorization, remember you need the critical values, this and that. So difference of two squares here. Remember 4, same as what? X squared minus 2 squared. So we've got a difference of 2 squares, 2 brackets, x minus 2, another bracket, x plus 2 is less than 0. So this is what we have. One of these must be equal to 0 for us to have what? The critical values. So x is equal to what? Negative 2 to the other side was going to be a positive, or x is equal to the positive 2 to the other side was going to be what? A negative 2. So this is what we have. Like I said, this is now a new question on its own that you're supposed to consider. So it's either you're going to use your number line, you're going to use the graphical method. Guys, it's up to you. As for me, I'm just going to use the graphical method. I introduced all the methods to you guys. So you choose which one. Using your graphical method, we can see that, remember, this is the new question. We are now looking into this question. Coefficient of x squared here is what? Positive. So we are going to have what? A smiley shape like this. There are two different solutions, so it's going to pass at two different points. So what? A smiley shape that we have. Right? From this, 1, positive. A is 1, which is what? Greater than 0. So this is the case. These are the roots, which are your critical values at negative 2 here, at positive 2. Negative 2, positive 2. So where is this function less than 0? Because this is our new question, like I said. So it's just like f of x is less than 0. Where is this function? Where is this whole part here? Less than 0. Below the x-axis. Remember, you compare them here on the x-axis. So below x-axis, that's where we have less than 0, negative values below. Above, it's greater than. So according to this shape, below the x-axis, these are the solutions that you take in between here. Minus 2 and what? And 2. In between minus 2 and 2. So therefore, our x is what? Greater than minus 2, but less than 2. Just like that. So guys, remember your solutions as we had from our topic of our inequalities. Just make sure you go through more revisions there. All right, so guys, let's communicate if there is any part that is having any questions. Let's communicate. Let's see. That was our 1.3 there. 1.4 again, solve for x, but this time but part of our exponential equations. So let's also take this one aside. It was 5 marks. All right, this was okay. This was actually a nice setup of questions that you just need to be very careful in your presentation. So actually, Gauteng, in terms of questions, yeah, you have to be very, very prepared. All right, you must be very, very prepared. So we are going to try, guys, work different provinces, compare with others. How do they ask these typical questions, guys? So that also as an individual, you revise, because at the end, your final will be the same when you're in grade 12. Your final is going to be the same. Whether it's this province, this one, but at the end, you have one exam. So it is good that you compare and see. How do they ask? What is the mind of this department? What is the mind of that one? And so on. All right. So anyways, guys, this is our question. Can we solve for x? Let's try to separate. But before that, we can even take this to the other side. Then we can do our separations. Let's just remain with a 0 here. I'm not saying it's wrong as it is, but it's just, for me, it's good to transpose. So I'm just going to take this. It's going to be negative 8 times 3 to the exponent of x plus 1. All right, so already there was a negative 81 on the left-hand side. Just rewrite as it is, which is equal to what? To 0. So this is our question, guys. Let's figure out. Remember, here, what does it mean? We need the 3 to the exponent of x. So we need that 3 to the exponent of x. 3 to the exponent of x, this one. This is the one that we need. So it simply means is 3 to the exponent of x, like this, raised to the exponent of 2, this one that is remaining. That is remaining there, like this. It's one and the same. Minus 8 times, we need the 3 to the exponent of x. And we have it here, 3 to the exponent of x. But look here, there is a plus 1 here. What does it mean? It means that was a multiplication of 2, 3 to the exponent of, it was like this, 3 to the exponent of x and 3 to the exponent of 1, like this. It was a product so that we add the exponents. So 3 to the exponent of 1, guys, is the same as what? It's just same as 3. But it was to the exponent of 1. All right? Minus, do we have x here? We do not have x. So why worried about that number? Just leave it like that. We do not have x. Be worried on separation of the part where we have the x, where we need this 3 to the exponent of x. We need to properly see it. What is it that is affecting that? Is it by product? Is it as an exponent? We need to properly see it, separate it properly. All right? So this is our condition. So you can even just try to rewrite this as 3 to the exponent of x to the exponent of 2, like this, minus 8 times 3, because these numbers, they do not have x. So you can even multiply them together. 8 times 3, that was going to be negative 24 times 3 to the exponent of x, minus 81. That's equal to 0. All right, so that's it, guys. This is where we are. This is where we are. At least it's much simplified now, but nothing has changed from the previous step here. We just multiplied 8 and this 3. Nothing has changed there. We still have the 3 to the exponent of x separated. So you can introduce, guys, a constant in place of that 3 to the exponent of x. We can introduce something because it's a quadratic equation, this one. But it's just a disguised quadratic equation. They are disguising it. But this is to the exponent of 2, guys. So looking into this, let k be equal to 3 to the exponent of x. We can properly see it. We are used to that one. So where you see 3 to the exponent of x, this one, cover it like this. And put what? And put a k there. So if you put a k here, what are you going to have? It will be k squared. We have another part. This one, it is now represented with k. So it's k squared. All right? Minus, this is 24 times what? 3 to the exponent. This one, you'll represent with what? With k. So that's 24k like this. Minus 81. We do not have k here. So it just remains as it is. So that's equal to 0. Just like that. Like I said, you have a new equation in terms of what? In terms of k. Solve this. You are used to this type as a quadratic equation. You are used to solve this type of an equation. Is it you are using a factorization method? Is it you are using your quadratic formula? It's up to you. So using factorization method, guys, as you can see, the coefficient of k squared is 1. So you're just going to take advantage of that. 2 brackets equal to 0 here. So we've got k and k here. So the factors, negative 81. Remember your factorization concept, guys. We need the products or the factors of negative 21, which will add up to what? Negative 12, which will add up to negative 12. Negative 24, I mean, this one, negative 24. So which factors do we have, guys? Negative 81, 2 numbers. You multiply 2 numbers, you get negative 81. Try 27 and 3. There's something about 24 from these ones, but 1 must be negative here. 1 must be negative. If we multiply this, we get negative 81. If we add negative 27 plus 3, that's negative 24. This is what exactly we want. This one, if we add, we are going to get a positive 24 here. If we add these two, 27 plus this, it was going to be positive, not negative, not this one. So this is totally out. What satisfies both conditions? That you multiply, you get negative 81, you add, you get negative 24 is here. This is the part which satisfies exactly what we need. So we need negative 27 and what? Positive 3. So one of these brackets, guys, as we do understand, must be equal to 0. So the negative 27, guys, to the other side was going to be what? A positive. All right. Or our k is equal to positive 3 to the other side was going to be what? A negative 3. We solved an equation that we were not asked. No. We're not asked about this k in our question. The question is for x. We need to solve for x. How did we end up with the k? We introduced it. We said let k represent something that carries x. 3 to the exponent of x. So let that part be on our final solution to say that k now, let's bring back 3 to the exponent of x is equal to what? 27. Or the k that we said it is 3 to the x, bring it back. It is equal to what? Negative 3. For x, we are solving for x, our equation, not k. It is something that we introduce. That's why we had to write let. We are introducing something that is not part of our question. Now, this is part of our question. Let's solve for x. Is it possible for us to solve here? Yes, we can raise 27 as 3 to the exponent of 3 as a product of its prime factors. But if you do not understand, guys, the calculator is there for your assistance. Remember, I said, I don't know, let's just change. I think this fix is going to affect us. 27 like this is equal to, then you say shift fact 3 to the exponent of what? 3. Shift fact. So 27 is equal to, then it's shift, go to that fact here, this one, fact on B, this one. So it's 3 to the exponent of what? 3. Guys, once we see this, same basis like this, it automatically tells us that the exponents are the same. So therefore, x is equal to 3. Equate the exponents. Is there any solution that can ever happen that a number is raised to a certain exponent, then we get a negative? A number was positive, then it is being raised to a certain exponent, then you get a negative. Guys, this cannot happen. This can never happen. So here, we do not have a solution. There's nothing like that. Here, negative, this one. Which exponent, guys? If you have that exponent, guys, the comment section is there. Let's communicate. I want an exponent that I will put here. If I put that exponent, my answer is going to be negative 3. Guys, if you have that exponent, you will be the first one. Let's communicate on the comment section, but there's nothing. Okay? Do not try that because remember your exponents, guys. Even if we raise to an exponent of a negative, is it a positive? Is it? We cannot get a negative number from a number which started as a positive. This is the part of your exponents that you know. So that is why being bold like that, you are also supposed to be bold like that in exam to say, no, there's no solution because of this reason. All right? You are supposed to have that. So this is your case, guys. Make sure you go through your questions. Make sure you go through your typical revisions. Understand the basics of each and every topic. All right, let's see another part that we are given in this case, which was 1.5. So 1.5 here. This was, again, solve for x. 5 marks. So we are under our equations, under the sets. So again, I'm just going to rewrite this equation, guys, because of the space that I'm having here. So let's see. what we had. So it was question 1.5, where you are given minus the square root of x minus 1. So the square root was covering this. Then after it is plus x minus 1 is equal to 2. This is what you're given. So remember the concept, guys, of first change of subject. The case of change of subject, to say we need to make sure we have got what? A Z on its own, this part here of a Z, this one. We want to make it to be on its own and be a positive. So how can we make this to be positive? Because it's carrying a negative. It's up to us. We can take this to the other side of our equation like this. We can transpose it, take it so that it crosses the equal sign. And take these two to the other side of our equation. So it will be like this, guys. Remember, on the left-hand side, this is what you have. Yeah, this one, on the left-hand side. So it will be x minus 1. You take the 2, so it is going to be what? Negative 2. You have taken it to the left-hand side. As you are taking it to the left-hand side, what are you doing? You are taking this to the right-hand side so that it becomes a positive, because it's negative. So it will be what? Positive on this side. So it will be x minus 1 under the square root with positive here. We are talking about the sign negative. It has changed to a positive. You can have it that way. If you someone who does not want to work with the negative, can avoid that. So here we've got what? Minus 1 minus 2, which is what? Minus 3. So x minus 3 is equal to the square root of x minus 1. We have it as a single side like this. Once you have it, guys, remove the square root by what? Squaring both sides. We know this way. Square both sides. You have to square both sides in that case. So by squaring both sides, guys, we are simply removing the square root here on the right-hand side where there is a what? A square root. So it will be x minus 1. What about here on the left-hand side? Expand your brackets. So you can have 2 brackets, or you use your identities. Remember the a minus b squared identity, which is a squared minus 2ab plus what? B squared. Guys, no, these, or just expand your brackets, 2 brackets there. This is your a, this is your b. So we're going to have a squared. So our a squared, that is x squared. So you're going to have x squared minus 2ab minus 2 times a times b, which is 3. So that was going to give us what? Negative 6x plus b squared. Our b is 3. So 3 squared is what? Is 9. So this is what you're going to have with your expansion. The way that you expand, guys, it's either you're going to use 2 brackets, expand those 2 brackets. Let's communicate. If you're having the same answer, then we are together there. All right. So this is where we are. Remember, it's an equation, quadratic equation. Highest exponent is now 2. So the format has to play a role. Ax squared plus bx plus c is equal to 0, the format of our quadratic equation. So you're forced to take the x to the other side, the minus 1 to the other side of our equation. So it will be x squared minus 6x. The x here will be what? Minus x. Minus 6x minus x, which is what? Negative 7x. The minus 1 to the other side will be what? Positive. So it will be 9 plus 1, which is what? 10. So that's equal to 0. This is where you are. The format of your quadratic equation here is important. Once you have this, guys, you can use your factorization, quadratic formula, whatever that you understand to solve this equation. So using factorization method, I'm simply going to have 2 brackets here. Since the coefficient of x squared is 1, and I have advantage of that one, this is x, this is x. I know that I'm done there. All right, then I move on to the what? The 10. Constant 10, positive 10. Which products? Factors of 10, but these must give us what? A negative 7 when added together, when combined together. So the products of 10, let's think of 5 and 2. So to have a negative, it means we must have -5 and -2. -5 times -2, that's a positive 10. If we add these two, -5 plus -2, that's a -7. So these are the numbers that we need, guys. The -5 and the -2. So x is what? The -5 to the other side was going to be what? A positive. Or our x is equal to the -2 to the other side was going to be what? A +2. Just like that. So I want you to solve whatever way that you understand. This is what you're going to have as your x values. But remember, these are the x values of what? The quadratic equation, this one that we solved here, this one. It gives us two possible values. It's a quadratic. That's the nature of this equation. It has two possible values. But as we must figure out back to our original question here, what we had, we must test it back there. These values that we are obtaining, are they going to satisfy that condition of our original equation as it was? Remember our original equation, it was minus the square root of x minus 1 plus x minus 1 is equal to 2. So let's take on this condition when x is what? When x is 5, we put a 5 here. So it's minus the square root of 5 minus 1 plus, in place of x, we put a 5. So this is 5 minus 1. So this is it. As you have it on your calculator, the way that it is represented. So bring back your calculator to the normal mode. As you have it on your calculator, this is the way that you present. So it's minus the square root of what? 5 minus 1. You move aside. This is 5. Sorry, that's a plus there. So you're going to have plus 5 minus 1. As it is there, you must present it on your calculator exactly as you see it here. This is exactly what we see. This is exactly what you must see on your calculator. All right? So it's equal to what? To 2. So that's 2 in this case. So everything here is giving us what? A 2. Is it equal to this 2? Yes. It is equal to 2. It is equal to what we have on the what? On the right-hand side. So as you can see, guys, our left-hand side, in this case, is equal to what? To the right-hand side. When x is what? When x is 5. So when x is 5, we need this solution, guys. When x is what? 5. So let's move on. When x is 2, we do the same thing. Substitute into that equation that we had before, our original equation. This time when x is what? 2. In place of x, we are going to substitute what? A 2 in place of x. We're going to put a 2. So let's see. As it is on our calculator, all right, in place of x, let's put a 2. In place of x, let's put a 2. So that was going to give us what? A 0. From our calculator value, that's a 0. Is it equal to 2? No. Is it equal to the right-hand side? 0 is not equal to the 2 there. The left-hand side and the right-hand side, they are not equal. So meaning to say, x cannot be equal to what? To 2. Because when x is 2, the left-hand side of our equation is not equal to the right-hand side of our equation. So x cannot be equal to 2 in this case. All right? So that is the case, guys. Can you just make sure you go through your questions? Don't forget the concept of a topic. What is it that you need under a certain topic? Once you know the concept of that topic, then do as many questions. All right? So that's your 1.5. Let's move on to another part. Question 2, which was simplify the following without using a calculator. 2.1, without using a calculator. This is our part. So there, guys, is just a matter of factorization. But in your factorization, you must consider the highest common factor. As you can see, there's something about this 5 to the exponent, 5 to the exponent, 5 to the exponent. There's something about that. So what is our highest common factor? Remember, it is the one that has got the least or the smallest exponent. We need the one that has got the least or the smallest exponent to be our highest common factor. So that is what? 5 to the exponent of 2022. So this is our highest common factor. So as we have it, we are going to try by all means to rewrite these ones in terms of that 5 to the exponent of what? 2022, because it is our reference now. So this is like a reference value for us to use our highest common factor. So let's start. 5 to the exponent of 2025 is going to be what? 5 to the exponent of 2022 like this times, for us to get 2025, what are we supposed to use? We are supposed to add a 3. So that's times 5 to the exponent of 3. We are supposed to add a 3. 2022 plus 3, that's 2025. All right. You do the same thing here. This is 3 already is there. So this is 3 times 5 to the exponent of what? 2022. Remember, we need this. But for us to have 2023, what are we supposed to do? You're supposed to multiply by 5 to the exponent of 1. So that if we add these two, we get what? 2023. The same thing in the denominator. But remember, this is your HCF. So there is nothing that you're going to do on this one. Just rewrite as it is. 5 to the exponent of what? 2022 plus 2024. So this is 5 to the exponent of what? 2022 times 5 to the exponent of what? To get the same 2024, what can we do? You're supposed to use a 2 here. So that 2022 plus 2, that's 2024. So we have managed to separate that 5 to the exponent of 2022 separately. We have it here. We have it here. We have it here. We have it also here. So what can we do with such? Factorize, guys. Factor it out. It is common throughout. So on the numerator, if we factor out 5 to the exponent of 2022, what are we going to have at the end? We factorize, we remove this. It simply means what are we going to remain with? We remain with what? 5 to the exponent of 3. All right? Plus, we remove it here. What are we going to remain with? 3 times 5 to the exponent of 1, which is what? 15. 3 times 5 to the exponent of 1. This is 3 times 5, guys, which is what? 15. Everything over what? In the denominator, we do the same thing. We remove it here. The 5 to the exponent of what? 2022. What am I going to remain with if I remove it here? I'm going to remain with a 3. So that's 3 plus, if I remove it here, I'm going to remain with what? 5 to the exponent of what? 2, which is same as what? 25. So this is what you're going to have. We factored the numerator, the denominator. So these two can cancel. They're the same. Under a product, we are allowed to cancel like that. So what are we going to have at the end? Simplifying properly, what are we going to have at the end? So these are the two brackets. So you just have to simplify those two brackets. 5 to the exponent of 3, that's 5 times 5, which is what? 125 plus 15 over 3 plus 5 to the exponent of 2, 5 times 5, guys, that is what? 25. So you add 125 plus 15. There you can even use your calculator. Do not even worry. So that is 140 over 28. 140 divided by 28, which is what? Which is 5. So this is what you're going to have at the end. So guys, do not even worry at the end. You can even use your calculator to evaluate that or to simplify that. So these are the typical questions. So just have to make sure you work out as many questions on that part. Solve for x and y simultaneously. We're back to our simultaneous equations. So this is it, guys. As you can see, the first equation there is just a little bit complicated. Let us just try to break it down, then we can see what is happening. 9 to the exponent of y there over 3 to the exponent of x is equal to 27. Let's have it, because these are exponents, so we're going to have them in simplest form. Remember, 9 in the base of 3, that's 3 to the exponent of 2. So it's going to be 3 to the exponent of 2y over 3 to the exponent of x, which is equal to 27 in the base of 3. That's 3 to the exponent of 3. Division, guys, of our same bases there, meaning to say a to the exponent of m, a to the exponent of n. We simply have to subtract. So we're going to subtract this. So it's 3 to the exponent of 2y minus x, which is equal to 3 to the exponent of 3. So we subtracted this part, exponents, because we are dividing the same base. Now that we've got here this base and this base being the same, and we are saying these two are equal, these two, what can we do? We equate exponents. So from there, we can equate the exponents. So it simply means 2y minus x is equal to what? 3. That is what it means. From this whole part that we are seeing, so you can even make y the subject or make x the subject. So it is easier for us here to make x the subject. The minus 3, the minus x to the other side will be what? Positive x. You take the 3 to this side, so it will be what? 2y minus 3. So this is it, guys. From our equation 1, we are going to have x is equal to what? 2y minus 3. X is equal to 2y minus 3. So I want you to go through this part, guys. Know your what? Exponents. You solve that part, you create an equation from there. So with this as my equation 1 simplified and this as my equation 2, I'm simply going to substitute where x is into equation 2. The value of x, where I have x, here I've got x. Here I also have x. Wherever I see the x, I'm going to substitute that part. So it's going to be what? 2y minus 3 squared. This is x squared plus y squared. All right? Minus 15 is equal to what? Minus 5x. Minus 5xy like this. Guys, is it different to minus 5yx? It's one and the same. It's a multiplication there. It's a multiplication. So we can write it as minus 5y into x so that we properly see the part of x on its own in a bracket. Not to say we write the minus 5, we put the x, which is 2y minus 3. Then after that, we put the y there. Then we end up even forgetting to multiply because we are thinking there are two different things. It's a single term. Take it as a single term. Into what? Our x. 5y, like this. Minus 5y into x. Our x is what? 2y minus 3. Just like that. So this is what we have, guys. Just one and the same thing. So you had to make all this is being shown. It's part of your calculations. Then from there, you can simply expand your brackets. Remember our identities, guys, or just open 2 brackets there, or we use that identity of a, okay, guys, I've written this identity a lot of times, but anyways, let's see it. A squared minus 2ab plus what? B squared. So that is our a in this case. Let me explain because it's just a little bit like there's a term of 2y that you have to consider there. So this is it. A squared, as we have it on our formula, when I have what? A squared. This is part of your a, which is 2y. So it was just going to be 2y squared. 2 to the exponent of 2, which is 4. A y to the exponent of 2, that's y squared. That is the part of what? A squared. Minus 2ab, what does it mean? This part of minus 2ab, it means minus 2 times a, which is 2y, times b, which is 3. So you multiply minus 2 times 3, minus 2 times 2 times 3. So that's minus 4 times 3, which is what? Minus 12. So that's minus 12y. That is the case. And the same thing here, b squared, the last part is b squared. 3 squared, 3 as it is. So 3 squared is what? Is 9. So you've expanded, or you can just open 2 brackets, like I said, guys, then solve So that's plus y squared minus 15 is equal to, we expand this part here, minus 5 and minus 2, and this positive 2. So minus 5 times 2, that's minus 10. So you're going to have minus 10 y squared. Then we have got the minus 5 and the minus 3. So it's going to be positive 15. So that's minus minus, which is what? Positive 15y there. Just like that. So from there, collect your like terms working with the left-hand side of our equation. What is on the left-hand side? Simplify there. What is on the right-hand side? If they are like terms, simplify. So on the left-hand side, guys, we've got like terms here. We've got this part of y squared here, 4y squared plus this y squared. So it's 4 plus 1, which is what? 5. So that's 5y squared. Then this part of y is just on its own. So that's minus 12y as it is. Then the numbers we have got here 9 and what? Minus 15. So 9 minus 15, that's a negative 6. So that was going to give us a negative 6. All right. So this is equal to the right-hand side. We do not have like terms, so just rewrite as it is. So just rewrite this part as it is. Then collecting the terms now to one side of the equation. As you can see, guys, this is a quadratic equation. Remember the format. One side must be equal to 0. So you're going to take the minus 10y squared to the other side. It becomes a positive. So 5 plus 10, that's 15y squared. The 15 becomes a negative. So it's minus 12 minus 15, which is what? Negative 27y, like that. Already, we had a minus 6 there. And that's equal to 0, just like that. As a quadratic equation as it can be reduced. We can reduce our quadratic equation before solving it. It's not always that we just have to work with these bigger values. We can even reduce them. We can see that from this equation, 3 is the highest common factor. So just reduce by what? By 3 by 3. If you can notice, then reduce. 15 divided by 3, that's 5. So we've got 5y squared minus, this is going to be 9y minus what? Minus 2. That's equal to 0. So this is what we have. Using your factorization, quadratic formula, whatever that you're going to have, guys, we know that we're going to have the values of y. So guys, I want you to use whatever method that you're going to have in your simplification. All right. So I'm just going to try use our factorization. Remember your cheat method, guys, 5y squared minus 9y minus 2. Because the coefficient there is not 1. I'm going to take this to the minus 2. You multiply it to the minus 2. So it was going to be y squared. Remember, it's no longer there. So it's y squared minus y. Minus 2 times 5 is what? Negative 10. You factorize as usual, guys. You are used to this when the coefficient here of y squared is what? Is 1. So you focus with what? The constant. What is our constant? In our case, our constant is what? Negative 10. We have factors of negative 10, which add up to negative 9. So that's negative 10 and 1, isn't it? Negative 10 and positive 1. So remember, we stole this 5, multiplied it here. Let us bring back to our equation. Wherever we see, to our brackets, wherever we see the y here, wherever we've got the y, we put that 5. Factorize where possible. Factorize where possible. 5 is common in the first bracket. So we've got y minus 2. 5y and y, that's y minus 10. And 5, that's minus 2. Into what? 5y plus 1. The second bracket cannot be factorized. This one, the second one, cannot be factorized. It cannot be factorized. Second one. So this is what we have got. The two brackets. The two brackets, y minus 2, 5y plus 1. So just like that. So this is what we have. Guys, obtaining these two brackets. Guys, I know you've got so many tricks of doing that. Can you do that? Yes, just a verification to say your answer is supposed to be like this. If you're using factorization, you can start with this bracket, and with this, any bracket can start, guys. All right. So let's solve either one of these brackets is equal to 0. So y is equal to what? Y is going to be positive 2. Or we take this 1 to the other side, was going to be a negative 1. We divide by 5. So that's it, guys. Y is equal to what? Negative 1 over 5. These are the values of y that we're obtaining. Since we are dealing with a quadratic equation, we know that we're going to have what? Two possible values. Two values of y there. Substitute into the equation where we've got x as the subject. Here, x is equal to what? 2y minus 3. Remember that. So we are going to substitute that part into our equation. Remember, x, 2y minus 3. For us to have the values of x, which corresponds when y is 2, we substitute there in place of y. So that's 2 into 2 minus 3. So it was going to be 4 minus 3, which is 1. Is that so? All right. So this is the x value. Then we do the same thing when this x is, when this y is what? Minus 1 over 5. So our x is going to be 2y like that. So it's 2 into minus 1 over 5. Then whatever that we have, we're going to subtract 3. So guys, you can just use your calculator straight forward. Yes, straight direct. That's 2 into minus 1 over 5 like this. Close the bracket. Subtract 3 like that. So that is minus 17 over 5. So this was going to be minus 17 over 5. You can even write them as points, guys. Remember, when solving these simultaneous quadratic equation like this, guys, which are simultaneous. These are just points, guys. You say x and y as a point. You calculated x and y. So you can even have them as a point. When x is 1, y is what? Y is 2. That is what we mean. When x is 1, y is 2. And when x is this, minus 17 over 5. This one. Y was what there? This one. Minus 1 over 5. You can write it like this if you want. Or just conclude when x is this, y is this. When in words, you can do that. So you see, guys, this is how our equations are like. This is how our equations can be like. All right, so let's just do more revisions. Another part, it was the roots of the particular quadratic equation. We do not even know it, but we are given that these roots are going to be given like this. As we do understand our quadratic formula, x is equal to minus b plus or minus what? The square root of b squared minus 4ac over what? Over 2a. So we are solving using our quadratic formula. Determine the values of p for which these x values will be non-real. Non-real. For us not to obtain any x value, to say we do not have x values, that is to be non-real. They do not exist. When our delta from the nature of roots are explained, when our delta is less than 0, when it is a negative, we do not have roots there. The roots are referred as non-real, does not exist, imaginary. Remember, delta represents what? B squared minus 4ac. This is your delta. So already it is there, guys. B squared minus 4ac, this one. B squared minus 4ac. What represents this? It is here, under the square root here. It is already there, this one. So knowing these guys is important. They just try to confuse you in as much as they can, these people. It's exam, remember, it's a test. So try to understand. So your delta, for us to have non-real roots, your delta is supposed to be less than 0. It's supposed to be a negative value. And our delta is already there. It is already here. You can see it under the square root. This is our b squared minus 4ac. So we're simply going to take that as it is 16 minus 4p as it is, guys. We're just repeating as it is, minus 4p. All right. So this is what? 4p like this into what? Minus p plus 5 like as it is, but it is less than 0. Meaning to say we have formed an inequality from this statement. We have formed an inequality. That's an inequality that we have formed. Guys, we are done, guys. You see, guys, I want you to see, test. It's a combination of topics here. The nature of roots, it played an important role in describing the nature non-real. Your delta is less than 0. That alone is the nature of, here we have applied the nature of roots. But as we have applied it, guys, here we now have a new question. It's no longer about nature of roots. No, it's about inequalities. So do not keep in mind, I'm under nature of roots. What can I do? I'm under nature of roots, nature of roots, nature of roots. We are now under inequalities. So if you know how to solve this here, because this was an inequality, you see, quadratic inequality. This is this exactly same thing that we are having here. So let's expand and see, guys. All right, so that's 16 minus 4p, distribute this bracket. Let's see here. So what are you going to have? Negative to negative, that's positive. So that's 4 p squared. Negative to positive, that's negative 20p, which is less than 0. All right, let's collect. We do not even have like terms here, so we're just going to rewrite as what? 4p squared minus 20p plus 16 like this is less than 0. Remember, starting with the highest exponent, the linear to the constant. And as we do understand, we will need the critical values, but we can even reduce this before the critical values. Just like the previous case, we saw that we can reduce. 4 is common, is the highest common factor here between these numbers. So we reduce by what? The highest common factor. All right, that's minus 5p plus 4 is less than 0. So guys, as we can see, simplified, it's easier now to factorize so that we can have our critical values at the end, where we have the coefficient, I mean this part of p squared, coefficient of p squared, it's 1. So it simply means we're going to have p here. We're also going to have a p here. So what are the products from what? The 4 here. We need the products of 4, which will add up to what? Negative 5. The products of 4, which will add up to negative 5. Which numbers are you talking about? Minus 4 and what? Minus 1. You multiply, you get a positive 4. You add, you get a negative 5. So this is what we need. All right. So we've got minus 4 and minus 1. So we can have our critical values from there. So what will be our critical values? Let's solve p minus 4 to the other side. That was going to be a positive. So p is equal to 4, or the minus 1 to the other side was going to be what? A positive 1. Just like that. With these critical values, guys, we can bring them now depending on the method. Are you going to use the number line? Are you going to use the graphical method? It is up to you. So in this case, I'm going to use the graphical method. As you can see here, the coefficient of p squared is what? Is positive. So meaning to say you're going to have what? A smiley shape like this. This is 1 and this is 4. So where is it that our function is what? Below the x-axis, that's less than 0. It's what? Negative. So it's what? Below the x-axis here. Meaning to say p is in between 1 and 4. Right? Remember, guys, this part. So p is greater than what? 1, but less than 4. Just like that. So these are the values of p within the interval that we are given. All right. So these are the values of for which x will be what? Non-real. If you substitute any value of p from that interval here, you are not going to get any solution. You are not going to have any solution from there. That is what they're trying to say. Non-real, meaning to say there is no solution at all. Within this, take any value and test it. Anyone that you want. You will see that there was no answer there. All right. If the cos of 24 degrees is equal to k, remember when you're given this type of equation, guys, we're just going to need a triangle that we can use. So this is 24 degrees. The cos is equivalent to what? Cos 24 degrees is equal to k over 1. Remember your SOHCAHTOA concept. SOHCAHTOA. Cos is at adjacent over hypotenuse. So this is it. According to 24 degrees, adjacent this side is k and our hypotenuse is 1. Using your Pythagoras theorem, guys, you can find the third side. So this is hypotenuse 1 squared minus k squared, guys. So it was going to be 1 minus k squared. Okay. Let's just put this one, guys, as an unknown value. So k squared plus that unknown value. Maybe it's x, maybe it's y, whatever that you want here, squared, is supposed to be equal to what? Remember, hypotenuse squared, which is 1. So this is the one that I'm having here, 1 squared. And you need to find this. So it's going to be to the other side there as what? 1 squared minus what? K squared. So guys, do not even worry about that. You introduce the square root. What is 1 squared? 1 is 1, guys. Then you introduce the square root. So this one was going to be square root of what? 1 minus k squared. All right. So there, guys, I'm not going to talk much. We understand this to the fullest. So the cos of 336 is in which quadrant? It is more than 270. So it lies in the third quadrant here. So let's reduce it, guys. Remember, in the third quadrant, we are supposed to have a condition of 360 degrees minus x. So which acute angle are we going to subtract so that we get 336? Which acute angle that we have here? So it's simply 360 minus 336, which was going to give us what? 336, it was going to give us 24. That's 24. So in the fourth quadrant, guys, this is for cos. Remember your cast concept. Cos is positive there. So this one is exactly equal to positive cos 24. And we have that cos 24, guys. It is the one that we are given here. Cos 24 is what? Is k. So it is equal to k. Just like that. It is equal to k. All right, let's see another part that we are given. This is 3.12, 1 minus sine squared minus, there's a negative there. So let's get rid of the negative. This is same as 1 minus, it is the same as this, guys. Sine of minus 156 degrees squared. This is what it means, the sine squared that we see there. Sine is squared. But remember, as a negative angle, negative angles, sine of minus x as a negative angle is equal to what? Minus sine x. So this one is going to be negative. It is going to be 1 minus the sine of a negative. It means minus sine of that. So it's minus sine of what? 156 degrees raised to the exponent of 2. So when it is like this, it is no longer valid, as we can see, because a negative, guys, when you raise this negative to an exponent of 2, it's going to be what? It's going to be positive. So it's no longer valid there. So what we just need to figure out, guys, is where do we have this sign of 156? In which quadrant? Where do we have what? 156. The second quadrant. In the second quadrant, your angle is 180 minus what? X. Remember, this is X. This is 180 degrees plus X. This is 360 degrees minus what? X. So in the second quadrant, we are supposed to have that 180 minus. So if we subtract this 24, 180 minus 24 is what? That's 156. So it means it was going to change to a sine of what? 24, sine of the acute angle. Remember, the sine of 180 degrees minus X is equal to what? The sine of X. So as we are saying, our X is the acute angle, which is this one, 24. 24. So it is equal to sine of what? 24, which is this sine of 156. So it was going to be like this, minus the sine of what? The sine of 24 like this, squared. The sine of 156 degrees and sine of 24 is the same. So this is it. 1 minus, remember guys, negative squared becomes a positive. We can even cancel that one. So what is sine 24? Sine 24, sine opposite over what? Hypotenuse. So that is the sine of 24 here. So it's going to be opposite the square root of 1 minus k squared over hypotenuse, which is 1. But we have to square this. Remember, guys, squaring. When you square a square root like this, where you see a square root and you square it, you're just removing that square root. It is just automatically removing it. So it was going to be minus 1 minus k squared. Remember, we have removed the square root. Over 1, does it affect? Does not affect at all. So let's expand our brackets. 1 minus negative times 1, that's negative 1. Negative times negative k squared, that's positive k squared. So 1 minus 1, that was going to cancel. And you remain with what? You remain with k squared at the end. So it was going to be k squared. 1 minus 1 was going to cancel. So that was the condition of your question, guys. So these identities, guys, ratios, these just need to know the equivalent, what is corresponding to that part, guys. All right. What exactly is corresponding. Simplify again on this part, as we can see, guys. Just a matter of understanding. I've been talking about this sine of minus X. It's a negative angle, this one. No, both positive and what? Negative angles. Negative X. Remember I talked about this. This is X minus what? X minus 180. This is minus 180 minus X, or minus X minus 180. This is X minus 360. These are negative angles. This one, negative angles. For positive angles, this is X. This will be what? 180 degrees minus X. This will be 180 degrees. The ones that you are used to, 360 degrees. Guys, the way that you revise this part to understand that you know each and every quadrant. It is the same way even for the negative angles. It's only that your teachers don't tell you. The way that you memorize this, the same way you're supposed to know this one. If it is going to be the opposite way, guys, I do not know the way that you're going to put it there. How are you going to work it that way? But if it can be something that you can actually analyze and figure out, know these angles. So we are given a comparison of positive and negative angles. All right. So working with this, what we're going to have, because sine of minus X is a negative angle, this one. So it was simply going to give us this 3.2. I'm just gonna write it here. So it was gonna be equal to what? The sine of minus X was gonna be minus sine X. Remember, this is where we have what? Minus X in the fourth quadrant. So from our cast concept, this is the quadrant for cos, not for sine. So that's why I'm saying our sine is going to be what? Negative. So that's negative sine of X. All right. Times X minus 180. Where do we have X minus 180? In the third quadrant. which is the quadrant for tan, not for sine. Sine is what there? Sine is negative. So that's a negative sign again. All right, times the sine of 190 degrees. 190, where do we expect to have 190? Where is it? This one as a positive angle. 190 degrees is more than 180 in the third. So remember, in the third quadrant as positive angles, this is 180 plus what? 180 plus x. So to get 190, it's 180 plus what? It's 180 plus 10. 180 plus 10 is what? 190. But we are talking about a sine in the quadrant here, in the third quadrant for tan. So sine there is what? Negative. So it was going to be negative sine of what? The acute angle. If we're going to write a sine x, what is our x? The acute angle, which is what? 10 degrees. So it's minus sine 10. Everything is under a product. Everything under a product, as we can see. All right. Cos 360 degrees plus x. Once you see a 360 degrees, guys, remove it. It's a full cycle, that one. What do you remain with is what is your answer. You remain with what? The cos of x. Whenever you've got that full cycle, remove it, guys. Cos 90 degrees minus x. Remember your co-function. This is the sine of x exactly. Equivalent to the sine of x, all right? Then the cos of 100. Let's figure out the cos of 100 is going to lie in which quadrant? 100 is more than 90 in the second quadrant. So in the second quadrant, we need the format of 180 degrees minus what? X. So it's 180 minus what to get this 100? To get this 100, what are we supposed to subtract from 108? We are supposed to subtract what? 80 degrees. So it's 180 minus 80. What represents our x is what? 80 degrees. 80. 80. So it is the cos of what? Sorry, it's a negative there because here in this quadrant, it is for sine. So cos is negative. So it's minus cos of 80 degrees. All right. This is where we are. So let's simplify, guys. They're going to just cancel some other things here that are common here. And also negative, 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 negative. All right. So this is where we are, guys. We're going to have what? Sine over cos. This one. Sine over cos. Sine over cos. Remember that? So it's going to be sine of x over the cos of x times. Here we've got sine 10 over cos 80. All right. We can change either the cos of 80 to a sine of 10. We can change a sine of 10 to a cos of 80. How? Remember that the sine of x is equal to cos 90 degrees minus x from your co-function. Also, the cos of x is equal to the sine of 90 degrees minus x. So you can change whatever that you want. So you can change, guys, whatever that you want. If you decide to remain with the sine of 10, therefore change this cos to a sine. So it will be what? Cos, this cos to a sine, it will be what? Sine 90 minus x. 90 minus what? 80 degrees. 90 minus 80, it's what? It's 10 degrees. So that's sine 10 degrees. We have reduced this. We have changed it to another function, co-function. It's one and the same. So as you can see, these two are the same, but the way they are written is like they are not the same. Sine 10 and cos 8, they're just the same. So you could have changed the sine into a cos. It was going to be cos 80 again. So these two are the same. They can cancel. What about sine over cos? Sine over cos is what? Remember, that's our tan. So it's tan x times 1 times 1. You're multiplying by 1, guys. There is no effect at all. Multiplying by 1 is just like 1 times 2 is 2. So 1 times tan x is what? Tan of x. So these are the questions that you might be given. All right, let's look into another question. All right, so that was 5 marks there. Then this one again, 5 marks. Prove this identity. Left-hand side is supposed to be equal to the right-hand side, remember? So I'm going to take the left-hand side. So our left-hand side got cos of x over 1 plus the sine of x plus 1 plus the sine of x over the cos of x. So guys, we can simply add these ones and see if you're gonna get this. Let's add guys, let's add. As you can see there, gonna need the LCD of the given denominators. Take these two as they are. That is the sine of x, 1 plus sine x and cos x. So that's it, guys. Cos of x, 1 plus the sine of x. So dividing this one and this one was gonna cancel. You remain with cos. So that's cos times cos. To the numerator, you multiply the numerator. So that's cos x squared. You remember it's cos times cos. So that's cos squared x plus you divide cos of x and cos of x. They cancel. So you're going to remain with this 1 plus sine x, which you multiply to the numerator. Again, there's 1 plus sine x there. So 1 plus sine x times 1 plus sine x is what? It's simply 1 plus the sine of x squared. Just like that. So guys, we're back. Expansion of brackets. So we're going to have cos squared of x plus, if you know a plus b squared, guys, use it. A squared plus 2ab plus b squared. You know it. It is the same thing. This is our a. This will be the same way as we know that part. So this is your a. The sine of x is what? Is your b. Just like that. So you're going to have what? A squared. The a squared, which is 1. 1 squared. A squared. So 1 squared is what? Is 1. So that's 1 plus 2ab. So it's 2 times a. Our a is 1 times b. Our b is what? The sine of x. So 2 times 1 times sine of x. That's 2 sine x. All right. Then the last part is what? B squared. Our b is the sine of x. So we raise that sine of x to the exponent of 2. So that's sine squared x like this. Everything over what? Cosine of x into 1 plus the sine of x. Knowing our identities here was going to help a lot because we can see that there are some identities that we need to put into consideration. And which part is it? The cos squared of x plus the sine squared of x, this one. This one. Remember your Pythagorean identity. This one is equal to what? Cos squared of x plus the sine squared of x is equal to 1. So if we take this one and this one, we are having what? A 1. A 1. A number 1, 1, 1. The rest here remains as it is. So you're going to have plus, remember here there was a 1 plus 2 sine of x. So it's 1 plus 2 sine of x. Everything over what? Everything over this cos of x into 1 plus the sine of x. So let's simplify, guys. As we can see, the numerator, we can add 1 plus 1, that's 2. So it's going to be 2 plus 2 sine of x, everything over the cos of x into 1 plus the sine of x. Where 2 is common, we can factor it out from the numerator. Get this 2 here, which is common. So let's take it out. Factoring out the 2, what are we going to have at the end? All right, sorry for that. So if we take out this 2, 2 divided by 2, that's 1, plus 2 divided by 2, that's 1. So it's just like the sine of x like this. Everything over what? The cos of x into 1 plus the sine of x as it was. So as we can see, guys, automatically the numerator, denominator are the same. They can cancel, giving us exactly what we are having on the right-hand side, 2 over the cos of x. This is exactly what you're given on the right-hand side. So this is how these questions, guys, are given for you to prove. Just like to simplify. Only that you have got an answer that you are working with. That's the only difference. You have an answer already to say your answer is supposed to be 1, your answer is supposed to be this. show that the answer is this. So make sure you do revise as much questions as you can, prepare for the exams which are ahead of time.